Have you ever looked up at the night sky and dreamt of visiting another planet? Mars, the red planet, has fascinated us for centuries. It's our cosmic neighbor, a world of rust-colored dust and grand canyons. For a long time, the idea of living there felt like something out of a science fiction film. How would we build our homes? Shipping heavy materials like metal and concrete all the way from Earth is incredibly difficult and expensive. It would be like trying to mail a car to a friend who lives thousands of miles away, but much, much harder. We need a smarter way, a more creative way, a way to build our first Martian neighborhood. So what if we didn't have to build our houses at all? What if instead, we could them? Think about it. On Earth, nature builds amazing structures all the time. A tree grows from a tiny seed into a towering giant, providing shelter for all sorts of creatures. We can take that brilliant idea and use it on Mars. This is the core concept of BioDome Genesis. We start with something small, a special kind of seed pod, and with a little help from the Martian environment, it grows into a complete home. It's a revolutionary idea that blends biology with engineering to create living, breathing shelters for future astronauts. This isn't just about saving money on shipping costs, although that's a huge benefit. It's about working the new world we find ourselves in, not against it. By using the resources already on Mars, like its soil and sunlight, we can create a sustainable way to live. These homes wouldn't just be empty shells, they would be active living systems. They would protect us from the harsh Martian environment, with its thin atmosphere and cold temperatures. They would be our partners in survival, helping us to create a little patch of Earth on a distant alien world. It's a truly exciting prospect, isn't it? The journey to Mars is one of humanity's greatest adventures, and how we choose to live there will define our future in space. Forget packing flat-pack furniture and tons of steel beams. Instead, imagine packing a suitcase full of house seeds. Each one holds the blueprint for a safe, strong, and self-sufficient home. This is the kind of forward-thinking science that makes exploration possible. It's about being clever, resourceful, and using the amazing power of life itself to build our future. Let's consider how these incredible living houses would actually work, shall we? So how do you grow a wall? You start with a fantastic fungus. Not the kind you find on old bread, but a special type of fungi called Mycelium. Mycelium is the root structure of mushrooms, and it's like nature's superglue. It forms a vast network of tiny, tough threads. For our biodome, we would mix these fungal spores with the Martian soil, or regolith, and a little bit of water. The mycelium would then get to work, weaving its threads through the soil, binding it all together into a solid, brick-like material. This living bioconcrete is incredibly strong, lightweight, and an excellent insulator against the Martian cold. The best part about these fungal walls is that they are alive. If a small crack appears in the wall, perhaps from a micrometeorite impact, the house can heal itself. The mycelium network would sense the damage and simply grow back over the crack, repairing the structure automatically. You wouldn't need a Martian construction crew with buckets of filler. The house would take care of its own maintenance. This self-healing ability is a game changer for long-term survival. It makes the habitat more durable and reliable, giving the astronauts inside peace of mind. It's like having a home with its own built-in immune system. Now let's look up at the roof. The roof of a biodome would be a transparent, multi-layered structure filled with a special kind of algae. This isn't just a window to the sky, it's a life support system. Using sunlight, the algae would perform photosynthesis, just like plants on Earth. In this process, they would absorb the carbon dioxide that the astronauts breathe out and release fresh, breathable oxygen. So, the roof of your house would literally be making the air you need to live. It's an elegant and efficient way to create a closed-loop system where nothing is wasted. This algae roof does even more. It would be a source of food. The algae are rich in proteins and nutrients, providing a renewable food supply for the crew. They can be harvested and processed into a variety of edible forms. The water flowing through the roof panels, which keeps the algae happy, also helps to regulate the temperature inside the dome, absorbing heat during the day and releasing it at night. This living roof is a power plant, an air factory, a farm, and a thermostat all in one. It's a beautiful example of how different biological systems can work together to support human life. The whole process starts with a single, high-tech package, the Genesis pod. This pod is much more than just a seed. It's a self-contained construction kit. Inside, it holds the dormant fungal spores, the algae cultures, and a suite of tiny robotic helpers and sensors. When a Genesis pod lands on Mars, it anchors itself to the ground and begins its work. The first thing it does is deploy small, autonomous rovers. These little bots are like busy worker ants. Their job is to scurry around the landing site, collecting Martian soil and bringing it back to the pod. Once the soil is collected, the pod carefully mixes it with a stored water supply and the fungal spores to create the initial bioconcrete paste. A robotic arm then extrudes this paste in a circular pattern, laying down the foundation of the dome. As the mycelium begins to grow, it solidifies the structure, layer by layer. The smart sensors embedded within the pod constantly monitor the growth process. They check the temperature, humidity, and structural integrity, making tiny adjustments to ensure the dome grows strong and healthy. It's a slow but steady process of automated construction, guided by artificial intelligence. While the walls are growing, a separate system works on the roof. The transparent panels are inflated, and the algae culture, mixed with water, is pumped into them. The Martian sunlight kicks off the photosynthesis process almost immediately, and the roof begins its work of producing oxygen. Power for all this activity comes from flexible, thin-film solar panels that are unfurled from the Genesis pod. These panels capture the sun's energy, storing it in safe, solid-state batteries integrated directly within the growing walls of the dome. This means the house has its own decentralized power grid from the very beginning. AI-powered drones also play a crucial role. They fly around the growing dome using advanced scanners to create three-dimensional maps of the structure. They check for any weaknesses or inconsistencies that the ground sensors might have missed, providing a complete overview of the habitat's health. This combination of ground-based robots, intelligent sensors, and aerial drones ensures that the entire construction is meticulously managed without any direct human involvement. The house essentially builds itself, using Martian resources and the power of the sun, all while we are watching safely from Earth millions of miles away. After several weeks of autonomous growth, the biodome is complete. The walls are solid, the roof is bubbling with life-giving algae, and the internal atmosphere is stable and breathable. Now, it's finally time for the astronauts to move in. They would enter through a secure airlock, and inside they would find a space that is not just a shelter, but a living partner. The air would be clean, the temperature comfortable, and the soft, ambient light filtering through the algae roof would create a calming environment. The astronauts' job would then shift from construction to cultivation, managing their living home. Living inside a biodome would be a unique symbiosis. The astronauts' waste, like carbon dioxide, would feed the algae. The algae, in turn, would provide oxygen and food. The mycelium walls would offer protection and insulation. It's a beautiful, self-sustaining cycle. This approach dramatically reduces the need for resupply missions from Earth, which are risky and incredibly expensive. By living in a habitat that provides for them, astronauts can focus on their primary mission: science and exploration. They can study Mars, search for signs of past life, and push the boundaries of human knowledge. This idea of growing our homes on other worlds is more than just a clever engineering solution. It's a philosophical shift. It represents a move towards a more harmonious and sustainable way of exploring the cosmos. Instead of conquering a new world with steel and concrete, we would be collaborating with it, using its own materials and the universal principles of biology to create a home. It's a hopeful vision for the future, one where technology and nature work hand in hand. This method could be adapted for other places too, like the moon or even asteroids. BioDome Genesis is a testament to human ingenuity and our ability to find inspiration in the natural world. By learning from the simple fungus and the humble algae, we can develop the extraordinary technology needed to become a multiplanetary species. It's a smart, efficient, and inspiring path forward. Growing a house on Mars might sound like science fiction today, but science has a wonderful habit of turning fiction into fact. And that is a truly exciting thought, because it means our future among the stars is not just possible, but it's within our grasp. Consider that.